Okay, welcome to the Cloud Mentorship Program, session 7. Today we are going to touch an important topic, and it's a very foundational subject when one works in the telco cloud domain. This is one of the foundational topic, which is the VNF lifecycle management. Many terms like the VNF package, VNF descriptor, VNF onboarding, VNF instantiation, VNF scaling. We are going to explain these concepts, discuss these concepts, and also see the role of the MANO functional blocks, I would say, contributing to these flows or to these procedures. I don't expect that it will be a long session, but it's, as I said, it's a very, very foundational and very, very basic. So let's start with a quick recap and a quick overview on the MANO. And if you notice the title is NFV Management and Orchestration, which is the abbreviation for the MANO. But the most relevant thing here is the pre-NFV release 4. So because in HCNFV there are releases, and starting from NFV 4, release 4, we start to see the introduction of new functional blocks that contributes to Kubernetes, container management, something called WIM. So I'm talking here about the basic reference architecture that most of the operators are currently working on, or currently, they have developed their cloud based on that reference architecture. So that's the MANO pre-NFV release 4. And we will be focusing heavily in this session on the VNFM and NFVO role. And as you see, there are 4 data repositories that are there in the framework, which is the NS catalog, the VNF catalog, NFV instance, and the NFVI resources. And if you can observe this kind of relation, only the VNF catalog is being fetched or being integrated, or both elements, like both network elements, NFVO and the VNFM, have access to the VNF catalog. So today we are going to discuss what is inside the VNF catalog. And then from integration points perspective, the NFV MANO has reference point with the EM, element management, the VNF, virtualized network function, the OS, SBSS, and the NFVI. And today we are going to assess the concept of a reference point and the interface. What's the difference between a reference point and what is an interface, and how can we differentiate between these two? Let's start. I'm just trying to see if someone is trying to join. Okay, we are 31 here, so only 8 are missing. I think we're fine. So I'm bringing you a story like the VNF story. What are the stages that construct the life cycle or the lifespan of a VNF? So usually it starts with something called the VNF package, and you might have heard this term being communicated, either you are a vendor or an operator or a cloud administrator. So basically, you usually ask the VNF supplier to provide a VNF package. The VNF package actually is how the supplier is packaging, or how is wrapping the VNF components or the VNF artifacts in a single file. Think of it as a zip file, like a classic zip file when you try to group or include multiple files that contribute at the end to one executable file, the way we do zipping for our stuff. So the VNF package, it's classically an archive that is provided by the VNF suppliers. It includes many files, something like VNF descriptor, like configuration files, the image itself of the VNF. And when we say image of the VNF, usually the image is closely coupled with the virtual machine. So whenever you boot the virtual machine, it needs to boot from an image file. So image is for virtual machines. Okay, it's not for VNFs, but for sure, for the cases where a VNF is a VM, like the IT as we discussed, like monolithic VNF. VNF is a VM. Then the image is for the VM, is the image for the VNF. But there might be a case when you find a VNF that consists of multiple VM types, and you may find that maybe a group of VMs like type A, they have their own image, and type B, they have their own image. But at the end, a VNF package will contain software image and will contain other additional files or additional artifactories. So we will see in the course, and you will see why it makes sense that we need a standard VNF package. So we need all suppliers somehow to comply to a certain standard so that they have a certain structure of the VNF package. So once you have the VNF package as a cloud professional or cloud administrator, usually your role is to make sure that this VNF package is onboarded. And when we say it is onboarded, this means that this VNF package is, the artifacts within this VNF package is being positioned in the right directories or in the right locations or in the right repositories. For instance, you may expect that you take the VNF descriptor, for instance, and you put it in the VNF catalog. So you have a repository called VNF catalog, and then you put the VNF descriptor in the VNF catalog. You may think, or you may assume, or you may expect that the software image that was there in the VNF package, at a certain stage, it should be positioned either in an image repository or, for example, in OpenStack, so that whenever you instantiate the VM, the image will be ready. So whenever you reach that state that all the artifacts of the VNF package are being positioned in the corresponding repositories, you get an onboarded VNF package. And for that, ECNFV defined many status, many levels of status of that VNF package. From onboarding perspective, you have created, uploading, processing, and onboarding. You have operational status of enabled and disabled, and you have usage state like in use or not in use. So there are many states defined by ECNFV, but at the end, our target is to make sure that this VNF package is onboarded. Once the VNF package is onboarded and all the artifacts are there in the corresponding repositories, there will be a stage where we start to instantiate the VNF, to read the VNF descriptor, to bring the image, and then spin up or instantiate the VNF. And once the VNF is instantiated, we usually say the VNF is onboarded. So the VNF is up and hopefully up and running. So to do all these kind of stages, ECNFV made like some nice standards talking about the VNF lifecycle, how to do the VNF lifecycle management, how to do the VNF package lifecycle management. So most of the content in the ECNFV corresponding standards are talking about the governance of these procedures, how to do these procedures, and we will touch these flows in today's session. So I will present that slide, show you this slide, and then I will open the door for the questions. So the VNF package itself, the one adopted by ECNFV, it complies with some sort of guidelines or standards called TOSCA. And you might have heard this term before, the TOSCA. TOSCA is the topology and orchestration specification for cloud application. That's a standard developed by an entity called Oasis. So ECNFV adopted the same format. And when we say the same format, think of see the frame on the right and the frame on the left. So on the right, that's how the package is structured. Think of a zip file, how when you unzip the file, you will see these folders. So this is how the folders are structured. There's something called TOSCA meta, you have something called definitions, something called files, and the main file that we usually all point to, or in the package it is highlighted, it's the YAML file. So that's the format of the VNF descriptor. It's .yaml. That's why you might have heard these terms before, Tosca, YAML. So Tosca are the format itself. YAML is the extension of the file, or YAML is the file format of the VNF descriptor. So the package itself, we call it CSAR. Usually you hear this term from the vendor. The vendor comes and tell you, I have the CSAR file. CSAR file is Tosca Cloud Service Archive. So that's actually the package, the name of the package from Tosca perspective. It's a CSAR format. So you will get a zip file, a packaged file, CSAR file with the structure on the right. Okay. And from files or from artifacts perspective, it will include basically the VNF descriptor, the VNFD, and the VNFD. It's a key concept that we work on the Telco Cloud, and we have similarly the same even in the containers ecosystem or the containers domain. So VNFD or VNF descriptor, it is the configuration template. It is actually how you model the VNF. So you may expect that when you go to the VNF descriptor, you'll see that this VNF consists of these VNF components, and these VNF components, they need this specific of resources, CPU, memory, and disk. And you know what? For this VNF component, you need 4 VMs, but for this VNF component, you need 6 VMs. This VNF component, for instance, the maximum VMs it can populate is, for example, 20 VM virtual machines. You cannot go beyond that. What are the policies that when met or triggered, you do scaling, you do healing? So you find everything about that in addition for sure to the internal architecture of the VNF and the VNF descriptor. So this is the main file. You may for sure plus the VNF descriptor, you get the software image of the virtual machines, because at the end, when you boot the virtual machines, you need to boot from the image. So you find the image in the package. Sometimes it is provided offline. It is common, but from standard perspective, it should be in the archive. You may find other arbitrary files like about manifest file, like for integrity and package authenticity. You may find acceptance test. You may find license. You may find anything that is relevant to the VNF in the VNF package. And for example, if you have an acceptance file in the VNF package, maybe that can trigger an automated acceptance. When you spin up the VNF, you call the file, you do the testing in an automated fashion. So that's the structure of the VNF package. And these are the files that you may find it whenever you open a VNF package. And these are the files that we will use in the flows for the VNF instantiation and VNF scaling. So let me pause here and see if you have any questions before we go to the next set of slides that will give us more visibility about the lifecycle management flows and lifecycle management interface.
Hello, Karim.
Hello, yes.
I see something called mrf.yaml. mrf is the main descriptor, or what?
Yeah. For example, the example that I'm bringing here, MRF, that's an IMS network function.
Okay.
Okay. So it's .yaml, that's the VNFD of the MRF.
Okay, great.
Okay. We have 3 questions. Let's take it one by one. So from Muhammad Shabu. Thanks for the Ahli t-shirt. Okay. Second thing, the application vendor shall provide the VNFD, or the NFVO vendor should build it. What is artifact? So the VNF descriptor usually comes from the VNF vendor. Okay. But there were some stages, like in the early years, where you meet suppliers or vendors, they only have the image. They only have the image, but they don't have a VNFD. Okay. And VNFD is mandatory for the MANO to interpret how the VNF is constructed and even start the whole flow of VNF instantiation. In that cases, the NFVO vendor or the system integrator sits with the VNF supplier and start to construct a VNF descriptor on his behalf. Okay, so essentially it comes from the VNF vendor, but sometimes the NFVO vendor or the SI can do that. What is artifact? Artifact is actually the file. It's just a term that maps to a file. So it's a configuration file or a template or whatever. So it's a file basically. Question from Majd. The main edit from our side as client is the VNFD. Yeah, usually it's the VNFD, but usually customers, they don't tend to do it by themselves. They ask the VNF supplier to do it because VNFDs will have versions and releases, and there will be some sort of change management process if you want to change something. So it is editable, but usually it is preferred that either the VNF supplier edits the file or we get his consent about doing that. Question from Carlo. In terms of all concepts you have explained, do they also apply for cloud ecosystem? Yes, and that's a good question. So the concept itself exists everywhere. So whenever you have a workflow, you have an orchestrator, you have something that triggers a flow, there should be a descriptor or a configuration template that the orchestrator or the automation tool reads it and interpret what to do and then do it. So the concept is the same. Maybe the term will differ. Here in HCNFV, we call it VNF descriptor. Maybe it can be somewhere deployment template, any other naming from other entities, but the concept is the same. Question from Salah. As each vendor should follow the Tosca deployment structure, any vendor VNFM can deploy any VNF, vendor agnostic. If this is the case, why we are facing multiple challenges in this part? So the question says that if the VNF package is standard and VNFD is a standard, then any kind of VNFM can understand this template, and then everything goes smoothly. Then why we have this kind of challenge that we are facing currently? There are many factors. First of all, this is the proposed framework by HCNFV, but it's not, I would say, this does not guarantee that it is followed blindly by all the vendors. So some vendors, they have some deltas and differences. Also, one of the main issues that most of the vendors, they don't want to provide their software image and the descriptor, because if you do that, you're exposing your application. So there's a friction between telco vendors because of that, because if you share the image, then you share everything, right? So there are friction in that case. The third thing is that most of the telco vendors, they implicitly push for a single vendor stack. They don't want to put dependencies on another cloud provider, another supplier, or a system integrator. So that's why they tend, I wouldn't say explicitly, implicitly, to have to put some obstacles that at the end influences the decision maker to go for a single vendor stack, plus other, non-technical obstacles. If you group all these factors, you'll find this is what making the challenges that we see in the actual telco cloud deployment. One question from Nisma. Could you mention the Tosca standard architecture in YAML 5? So Nisma, what you see in the right hand side, this kind of structure of the VNF package or the CSAR package, this is the Tosca standard. So Tosca sets the structure of the VNF package. So this is the Tosca standard. And the file itself, the VNFD itself, it complies also to Tosca standards. So the package and the descriptor itself. So that's where you see the Tosca. And .yaml is the format or the extension of the VNF descriptor that follows the Tosca templates or the Tosca standards. Okay, there are two questions, and then I'll continue. A question from Abdurrahman Ashraf. Software image here means the operating system or just software instance. Here, that's the software image for the virtual machine. So it is the operating system. from that kind of definition. That will be the operating system of the virtual machine. Iman says that some vendors, they use heat templates as VNF descriptor. Is it same like Tosca? Okay. So these templates that I'm explaining now, they are being interpreted by VNFM and NFVO, and they follow the HCNFV standards. So these are the Tosca stuff. If you don't have this kind of VNFM and NFVO, and you don't have this complexity, and you only have OpenStack, for instance, just OpenStack. So in OpenStack, there is also the concept of having templates, configuration templates that can automate the provisioning or automate the spinning up of the VMs and the corresponding configuration. And that's where the heat templates comes into place. So heat templates is something that OpenStack understands. And because of that fact that OpenStack understands heat templates, that's why the first generation of the VNFM, the one that is northbound to OpenStack, for example, I remember Nokia, they made the template in hot or heat template specs, so that they do it in a heat template that OpenStack understand, and then convey that kind of information to OpenStack without any kind of translation. But here we're talking about having a new layer that is there in the MANO with VNFM NFVO that is very teleco oriented. This is the Tosca template. We do a VNF descriptor, and then at a certain stage, we will see that the VNFM will translate this kind of attributes in the VNF descriptor into a language being understood by OpenStack, for instance. That can be heat template, that can be direct APIs, that can be anything. So let's proceed. Okay. Just a highlight, an overview about the VNF descriptor. Okay, so think now of a deployment template or a configuration template that does the modeling of the VNF. So it should describe what is this VNF, how it is structured, okay, what is the software image, what is the number of the VMs. So you should, whenever you read the VNF descriptor, you understand exactly what is the to-be state of that VNF. When you instantiate the VNF, what will be the structure or the architecture of that VNF. So in the VNFD, there are multiple constructs, like chunks of configuration. The most relevant one or the most significant one is the VDU, which is the virtualization deployment unit. And that VDU gives you an understanding, a description of a certain VNF component, how it is being deployed, how it will be there in the from operations perspective, like how the operational behavior, what kind of compute, storage, memory does it require, what is the structure of that VNF component instance. So you will see all this information in the VDU. But let me just remind you of the VNF component. We agreed that the VNF in Teleco consists of multiple VNF components. For instance, VNF component for control plane, VNF component for user plane, VNF component for transcoding, for encryption. So there are multiple VNF components. Okay. Each VNF component consists of VNF component instances, and that can map to the virtual machines. Okay. So basically in the VDU, you see a description for that virtual machine or for that VNF component instance. You will find that that VM requires X CPU, X memory, X storage. That virtual machine, it has internal connection point, which is the virtual NIC. This virtual machine will be booted from that software image. And then you have something called boot order. Boot order it's very smart attribute, because imagine if you have 3 VNF components. Okay. For that VNF to function, the VNF component A need to be booted first before B. And then ultimately you finish with C. So it's A, B, C. So in the boot order, That what determines exactly what VNF component should be booted first, and then what come later. Okay, and then in the VNFD you will see description about the virtual link, the internal connectivity, and the external connection point descriptor, which is how the VNF is communicating with the external world. And then another smart construct comes into picture, which is the deployment flavor. Deployment flavor. Okay, deployment flavor. You explained the VM requirement or the VM's personality in the VDU. In deployment flavor, I think it makes sense to say how many number instances of that VM you want to instantiate. So you find this information in deployment flavor. You talk about affinity or anti-affinity rules in the deployment flavor. For example, affinity. Do you want all these VMs to be hosted on one server? Or anti-affinity, you want to make sure that these VMs are scattered across different servers. You specify what are the monitoring parameters, what are the parameters or the monitoring objects to be monitored out of these virtual machines for sake of lifecycle management, for sake of scaling, for sake of healing. So you find a lot of information about how you deploy this kind of VDUs or VNF component in the deployment flavor. If we have time, I put some tables that explain this information elements into details. If not, I will send it to you. It will be there in the slides. But I need just to get the understanding of the structure of the VNFD. What do you expect if you read the VNFD, the YAML file? What would you get under this VNFD? Okay. Any questions for the VNF descriptor before we go to the other one? Okay. Very important concept that is mandatory to interpret HCNFV standardization standards and documents. Okay, thanks for the celebration. It was not me, but thanks. How do you interpret the term reference point, interface, and operations? So I extracted the MANO and the EMS and the VNF out of the HCNFV architecture. And for example, if you see that the VNFM, let me just be the laser pointer, the NFVO and the VNFM, they have a reference point, which is the OR VNFM. So that's a reference point, okay? It's similar to what we see in the 4G and the 5G and 3G, like the GN, the GP, the diameter interface, GX, GY. So that's a reference point, okay? The reference point, for example, cannot be used for compliance. You cannot ask the vendor, do you comply to OR VNFM? No, this is not the right question, because reference point is actually what construct a reference architecture, that it gives an indication that these two blocks communicate in a way or another in a reference architecture. But in order to go to compliance and what actually these functional blocks do in different contexts or in different scenarios, you need to start focusing on the interface. And for sure, we are here talking about an API, REST-based interface, okay? So you will always see the term exposed, consumed. So for instance, in the reference point OR VNFM, I'll just now say a phrase, and then we're going to digest it and explain it. When I say that there are multiple interfaces exposed by VNFM, and these interfaces, the majority of these interfaces are consumed by the NFVO. So let's now try to interpret what I've said. I said there are multiple interfaces exposed by VNFM. And if you see this kind of the way I drew the diagram, if you see this rounded black endpoint, if you see this black this rounded endpoint out of a logical object or a functional object, this means that the VNFM is exposing capabilities. This means that the VNFM is exposing capabilities. And when I say now I'm focusing, for instance, on the VNF lifecycle management interface, this means that the VNFM is exposing a VNF lifecycle management interface to NFVO. And this means that the VNFM, for instance, is exposing a VNF lifecycle management interface to the VNF. And the VNFM is exposing a VNF lifecycle management interface to the EMS. Are there other interfaces? Yes, there are a lot of interfaces. There's a performance management interface, fault management, and other many interfaces you'll find in the standard. But here I'm giving an example using the VNF lifecycle management interface. So what does this mean? If I may interpret the diagram, let's focus now on the VNFM and the NFVO. The diagram is telling you that VNFM is exposing a VNF lifecycle management interface on the NFVO. This means that that interface is consumed by the NFVO. So you should expect that NFVO will always be the one who initiate any kind of operations, not the VNFM, because the capability is exposed by VNFM and not by NFVO. It is exposed by VNFM and consumed by NFVO. So under the interface, there are a lot of operations. Now, if you see the text or the content on the left, the interface is called VNF Lifecycle Management Interface. It is exposed by VNFM, consumed by the NFVO. What is there are the operations that can be run under that interface. Think of the first, for example, take the second one, instantiate VNF. Instantiate VNF. So it looks like NFVO can ask the VNFM to instantiate the VNF, but it's not the other way around. VNFM does not ask NFVO to instantiate VNF. Why? Because the interface, again, is exposed by VNFM and consumed by the NFVO. That's how you interpret the diagrams. That's how you differentiate between a reference point, an interface, and an operation. Okay. Usually, if you want to ask about compliance, you ask a vendor for compliance. You have to ask compliance on the operation level. You have to ask for compliance on the operation level, not on the reference point and not on the interface. I hope you got this one. I will show you in the next slides some flows that actually based on that concept, but I need to get your questions first to make sure that we all have the same understanding. So the question in the chat. Okay, so there's a good question. What is IFA and SOL? So IFA is the interface and architecture. SOL is the solutions, and that's the naming each NFV is using. So IFA is actually what maps to stage 2 in 3GPP. That's where you get the logic, you get the flows, okay, you get the how the we call it information model, like how the data is structured. So that's like stage 2 in 3GPP. If you want to go to the bits and bytes, and for example, the exact specs of the APIs, you go to SOL. So usually when we ask vendors for compliance, we ask them to comply with SOL 003, SOL 004, whatever SOL. So SOL is a stage 3 in 3GPP. Same like stage 3 in 3GPP. Okay. So yeah, thanks, Mohammed. So for people working on 4G, for instance, 23.401 3GPP, that's stage 2. 24.301, that's the stage 3. That's the NAS thing. So it is very similar to 3GPP. Okay. Clear? That's a very foundational thing, the reference point, the interface, and the operations. Okay. Okay, I have 2 questions. Let me just go back because this section is important. So I'll go back. A question from Iman. When we say exposed and consumed, it is done by protocols or how exactly? So Iman, we're talking about APIs. Okay, so that means that VNFM is exposing an API, set of APIs for the VNFM, for the VNF lifecycle management interface. And these APIs are consumed by NFVO. So we're talking in the context of the APIs. So the protocol is always APIs. Another question from Tamer. I saw that NFVO is responsible for the end-to-end orchestration only, but it seems it managed similar to the VNFM. So NFVO, it has a role in 2 things: resource orchestration and network service orchestration. In the context of the VNF is part of the network service. That's why NFVO has a vital role. So still NFVO treats, even if it is one VNF, then it will map to one network service, then NFVO will be involved. So NFVO is the brain, and the role of the NFVO will appear in the coming flows that I'm going to explain. Okay. Okay. So now I want you to recall the concept about the VNF package, and imagine that a VNF package is onboarded. So there is now a VNF descriptor in the VNF catalog. Okay. And that VNF catalog is being, I mean, both systems, NFVO and VNFM, they both have connectivity and accessibility to the VNF catalog. So both can read and can see the VNF. Okay. So now I'm going to show you how the VNF is being instantiated. It is somehow informative. You can go to HCNFV and see the exact bits and bytes, but just to give you the overview. So the first trigger is that a specific administrator, a specific decision maker said, okay, now we have the VNFD of VNFX onboarded as a VNF package. Let's now start the instantiation of VNFX. So NFVO, with an API request, communicates with the VNFM, and the request is called create VNF identifier request, and then it points to the exact VNF descriptor that, if you can just please, if you can mute yourself. So the NFVO, it asks the VNFM to create a VNF identifier request. This means that it tells the VNFM, be ready, okay, because there is a VNFD in the VNF catalog we are going to use to instantiate a VNF. So before we instantiate the VNF, that's the pre-activity. We do something called create VNF identifier. So we create an ID for that VNF. And because this VNF exists now as a VNF descriptor, that's why in the first API request from NFVO to VNFM, it points to the exact VNF descriptor in the VNF catalog. So it tells the VNFM, let's start to do a record for that specific VNF descriptor for VNFX. So the request is create VNF identifier request. It specifies the VNF descriptor ID. It specifies the VNF instance name and other parameters. And as you see, post to here, that's the actual API request. And that kind of post, get this kind of things, this is what you see in the SOL, HCNFV SOL document. So the request comes to VNFM. VNFM locally start to create a record, VNF instance record, and then replies by 201 for API as an API response that yes, I created a record. In my local repo, and you know what? I gave VNF instance ID 22 to that VNF. So now NFVO knows that VNFM has created a record with that VNF, and the ID is 22. Anytime the NFVO wants to instantiate the VNF, the NFVO will just say 22, that I need to instantiate the VNF ID 22. Okay, so the status now we end this operation, these activities, by having a VNF instance record created at the VNFM. The VNF instance ID is shared with the NFVO, and then the status now VNFM sees the VNF as not instantiated. It is there as a record, but it is not instantiated. What will be the next stage is to instantiate the VNF. Okay, so that's the first initial step in the lifecycle management of the VNF. Let me go to the next slide. So now it is time to do the instantiation. Okay, I will explain the instantiation and then we'll take your questions before we go to the scaling. So NFVO, an administrator, decision maker, whatever team of the NFVO, organizational demand group, whatever, we are going to instantiate the VNF. The request goes to the VNFM, and this time it goes with the ID shared previously by the VNFM. Then VNFM starts to do something called create VNF lifecycle management operation occurrence. So VNFM is saying that I'm going now to work on this activity, and that's somehow a new context or an ID for that kind of activity. VNFM replies to NFVO, I accepted your request. And then VNFM in step 5 notify the NFVO that I'm going to start the process. I'm going to start the process. I'm going to do, when we say LCM operations type, in that flow, it is instantiation. Maybe in another flow, it is scaling or healing. But in 5, I will tell the NFVO that I'm going to start the instantiation of VNF instance ID 22. Stay tuned. I will come to you if I need support. In 6, that's a very important step because it shows the role of the NFVO. One of the roles of the NFVO, that VNFM goes to NFVO and asks for a grant request. A grant request here shows that VNFM doesn't have the visibility on the whole cloud resources. It only sees whatever resources consumed by the VNFs managed by that VNFM. For example, if that's Ericsson VNFM, so Ericsson VNFM sees his own VNFs and the resources consumed by his own VNFs. So now he wants to instantiate a new VNF. So he wants to make sure that there are resources available in the cloud or in that specific DC to cater or to host the new VNF. So then who knows this information? It is the NFVO. That's why the VNFM asks NFVO to grant that request. Give me your blessing that I can do that. And that's, you'll find that this will be a mandatory step at any lifecycle management procedure. VNFM doing his instantiation, doing his scaling, doing healing. He needs to consult the NFVO first, and that's the grant request in step 6. So in grant request, VNFM tells the NFVO, I need to instantiate the VNF. These are the resources, CPU, memory, and disk. From where he gets this information? From the VNF descriptor. And these are the parameters. Do you accept? Do you grant me the request? NFVO says, yes, I grant you the request. You can do the provisioning on data center 5 or data center 4 or any data center specified in the message. In step 8, that's the dialogue that happens between the VNFM and the Vim. It's not dialogue, actually, it is the APIs of the Vim. If you think of OpenStack, then VNFM will interpret whatever there in the VNF descriptor and then start to communicate with the OpenStack, either by OpenStack APIs or maybe by still OpenStack APIs, but using the heat template, the one that was referred by Iman. So in 8, that's where the VNFM communicates with the Vim, okay, with the OpenStack. Once this happens and the operation is finished, in step 10, the VNFM notify the NFVO that the VNF is instantiated. These are the allocated resources. If you want, as an NFVO, to update your repo about the allocated resources. And once the VNFM does that, it can start now to do what we call day 0 configuration and day 1 configuration with the EMS. Like put some configuration like IP addresses, logins, something that enable the VNF vendor team or tool to get in and push day 1 configuration, which map to service configuration. So that's an informative flow that showed the role of the NFV on the VNFM and the VIM as well, which is the MANO on the VNF instantiation. So you need to have this kind of visibility about end-to-end. If you want to go to more details, you have to find that from the standards. I'm sure you have many questions. So I'll stop here and then get some questions and then go to the scaling. What is the EMS role again, than other elements? EMS is the classic element management system that has been classically used in telco for FCAPS, fault management, configuration, accounting, performance, and security. So there is a possibility that once the VNF is up and day 0 is configuration, like you have the logins and the IPs, the O&M IPs, you ask the EM to connect that VNF and start push the configuration of day 1 configuration. So that's the role of the EMS in this flow. Any questions? The question is, heat template is the replacement of VNFD or both are required to instantiate an instance? No, hot template or heat template is something that this is an OpenStack related template. Okay, it's not in the level of the VNFM and the NFVO. So VNFD is mandatory using Tosca, that's the standard thing. But how to communicate with the OpenStack with the Vim, we have two options. Either you invoke a heat template on Vim, so that you do the instantiating of the VMs, creating the networks, attaching the storage using heat template, or using APIs direct to OpenStack and not using heat. So heat is not a replacement of VNFD. And even in my experience, whenever you have a strong framework for a MANO and orchestration, you don't use heat. This is my experience, but for sure, some vendors, and I acknowledge that some deployments are using heat. There is one question about how can I monitor this system and a response as expected for failure. So the monitoring part, we will discuss that in the monitoring or the FCAPS of Telco Cloud. That's a very interesting and dense topic. But the success and failure of the activity, this is something that we can comment or we can assess. For instance, if the VNFM is asking OpenStack to create the virtual machines, and that virtual machine is not created for some reason, the Vim or the OpenStack doesn't send the user or the VNFM an outcome that there is a failure. Usually, the user or the one who asked for this request must continuously interrogate the environment to check if it is already done or not. Okay, so sometimes there is an outcome. What I mean by outcome, for example, I ask a certain system to do a specific task. There might be two outcomes: positive outcome, like yes, I did it, or false outcome, like no, I didn't, or negative outcome, sorry, no, I didn't. And some other system, they keep silent. So what I'm saying that some of these procedures, they have outcomes, like for example, the classic API outcome, like it's 201, yes, no, so there's an outcome. But some others, they don't. And in that case, the system who asked, the main system who asked for this activity must continuously interrogate the environment if the activity is being completed or not. So you have the mix of both in these flows. In step 7, will MANO communicate with them to reserve the needed resources, or VNFM will do this? Okay, so Abdurrahman, let's differentiate. The term MANO, from standard perspective, MANO is the VNFM and NFVO and VIM. So MANO is the three of them. Okay, so MANO is the VNFM, NFVO, and the VIM. Reservation of resources, it was proposed by HCMFV, but it was not applied in reality. So reservation of resources is not there in most of the deployments, so it's not a practical approach. So there are no reservation of resources. But during the granting in the step 6 and 7, okay, NFVO maintain a repository that includes all the resources managed by that NFVO. For instance, I have 3 data centers, I have this number of CPUs, and the allocated resources and what is left. So he has already visibility on the available resources on the cloud. So whenever you ask to instantiate a new VNF, for example, that require 240 virtual CPU or CPU, NFVO will see in the repository, do I have these resources available or not? If yes, I will grant. If not, I will not grant. So no need to reserve resources because NFVO has already the visibility on the resources, and that's a basic thing or aspect of NFVO doing resource orchestration of the telco cloud. I hope this is clear. Okay. I will show you also another aspect of the lifecycle management, which is the scaling. But let me just have this question from Ahmed Dash, and then we move on. Since the granting procedure is controlled by NFVO, does that mean we have only one NFVO in the cluster to be aware of all resources in the cloud, or we could have multiple NFVO? So the standards evolved initially with the fact that you have one NFVO per cloud that see all data centers. But now there's a flexibility to have multiple NFVOs to have like NFVO per administrative zone, like NFVO handling, for example, X cloud, NFVO handling Y cloud, or NFVO handling attendees and NFVO handling the edge. So we can have multiple NFVOs. So standard allow that. Okay, so scaling. Okay, and what is scaling? So scaling maps 100% to the elasticity of the cloud. If you remember the definition from the NIST about if you have a cloud, then you should have elasticity. Elasticity of resources, this means that whenever you have a demand or an increase in demand, you do some sort of scaling, scaling up or scaling in. If you don't have this kind of demand and you want to release and relieve the resources, you can do some sort of a scale in, scale down or scale out. Okay, there are two types of scalings that you in the context of cloud. You have the horizontal scaling, and horizontal scaling is the one that you see here on the right. That's horizontal scaling, and you have vertical scaling, or the one on the left. So vertical scaling, scale up, scale down. Horizontal scaling, scale in, scale out. So in horizontal scaling, you essentially add a new instance of VM. Okay, and when you scale out, you take these VMs. So you add VMs with a similar configuration and similar flavor. Scale up, scale down, you actually increase the resources or decrease the resources of the virtual machine. If it is used to take 24 CPU, you will make it 32 virtual CPU, for instance. So scale up, scale down, it's a disruptive operation because you need to like destroy and the VM and then rebuild it again or restart the VM, and that's very disruptive. So that's why it was not embraced by HCNFV, and that's why it is not used in the telco cloud or HCNFV. HCNFV aligned to telco cloud deployments. So we are using essentially the horizontal scaling that we add the VMs. But what are the scaling steps? Do we scale with a VM or two? What is the maximum scale level? Can we scale like to go to endless number of VMs? All these parameters are there in the VNF descriptor. So you see all these parameters in the VNF descriptor. So you cannot scale to an endless number of VMs, infinite number. This is not the case. Each VNF has like minimum number of VMs and maximum number of VMs, and also it has scaling steps. What is like a scaling step that you would take, 1 or 2 or whatever. Okay, so the main takeaway, we are working usually on the horizontal scaling, scale in, scale out, same for virtual machines, same also for containers. That's the de facto scaling technique. All the parameters about when to scale and how to scale and the maximum number of VMs are all there in the VNF descriptor. So let me show you now how does it work for the scaling. So there are many scenarios or many network functions, network elements can trigger scaling. Okay, so scaling can be triggered from the infrastructure, from the VNF itself, from the EMS, from many entities. So I chose here the use case or the scenario where the trigger happens from the VNF. Okay, so the trigger is coming from the VNF. So you see here that in that scenario, VNFM is doing poll, is getting data from the VNF. Indicator value request, indicator ID. Imagine that, for instance, VNFM is interested in the certain metric or a certain parameter, or for example, CPU utilization, for instance, or an application-related metric. So VNFM is continuously pulling this metric, and in one you get continuous feeds about this metric. In two, the metric is sent to the VNFM. So based on the policy on the VNF descriptor that says, for instance, if that specific metric exceeds certain percentage, for example, we need to scale. So if CPU utilization goes above 80%, you need to scale. So VNFM reads the policy in the VNF descriptor, gets the metrics or the data from the VNF, and then decide that we need to scale. Okay, so that's point number 3. Internally, VNFM gets ready for that operation by doing something called VNF LCM operation occurrence and give it an ID, and then goes to the NFVO and notify the NFVO that, you know what, I've started to create a new procedure, lifecycle management procedure, and then in 6, the basic step, VNFM cannot do scaling without the consultation of the NFVO, without the blessing of the NFVO. So in step 6, I ask, as a VNFM, I ask the NFVO to grant my lifecycle management procedure. Please grant me request to do scaling. I will do scaling. It's not instantiation this time. These are the resources. These are blah, blah in the VNFD. And then NFVO checks, yeah, I'm okay, I'm not okay, and then respond with a grant response to the VNFM. And then classically, VNFM increase or add this VM by communicating with the OpenStack. Once the operation is finished, the notification is being sent to the NFVO that I did the scaling, and these are the resources allocated. NFVO will take this resource allocated and then update the repository of the resources that he has, so that he knows now that these resources are already allocated and not available anymore. So it is very similar to the instantiation, following the same theme and the same logic. For now, I know there's a lot of information, but I just want you to catch the logic and, you know, start to be comfortable with how these are structured. Any questions? Okay, one question from Sharif. In container environment, is the role of the VNFM is being slowly replaced by Kubernetes management? Yes. Based on my experience, there are a lot of intersection, a lot of common stuff that both do. So I believe that Kubernetes management or some solutions like Tanzu, like OpenShift, are somehow replacing 90% of the VNFM responsibilities. Telco vendors may argue but this is a fact. This is a conclusion that I reached out after working with many stakeholders like vendors, operators, interpreting what both entities are doing. So yes, Kubernetes management solutions are somehow taking the functions of the VNFM. Is it possible to make other NFV down if I don't have enough resource like priority? So Majd, you are asking if for some reasons there are no resources, so maybe NFVO can start to dismantle or drop other VMs for the new VMs, right? No, this is not happening. This is not happening because most probably the other VMs are actually belongs to other services, so that will impact on other services. So it's not like that. By the way, this concept exists in radio, in radio communications in the mobile, but it's not there in the cloud, at least in the cloud. A question from Iman: is scaling also depending on the licensing? It's a very good question, Iman. Most of the license models of the VNF vendors doesn't depend on the number of VMs. So license is not impacted. However, because of the fact that there might be a step where you need to consult an entity to make sure that license is there to do that scaling, some vendors of the VNFMs, like generic VNFM vendors, they did a VNF license management module inside the VNFM to make sure that that scaling is aligned with the number of license or the license consumption that is already there. So it is there in some of the products, but in reality, most of the license models of the VNFs are not depending on the number of VMs. And then question from Philo: how does the VNFD scaling flow handle situation where the VNF needs to be scaled out, but there are not enough available resources on the cloud platform? So simply, NFVO, if he believes that there are no resources in data center 5, he can recommend to the VNFM that, you know what, you can go to the data center 6, 7, 8, 9, 10. Okay, so you don't have to stick to a specific data center if there are other resources in other data centers. If it's mandatory to provision that VNF or scale VNF on that specific data center and there are no resources, then NFVO will not grant the request. As a cloud administrator, you can do a logic that not granting the request can trigger an alarm. And that alarm can be decoded in a way that fits to a capacity planning engine that makes sure that this kind of alarm is being countered by having a work order to the infrastructure team to deploy more servers or to have more capacity. So, you know, we have this kind of flexibility to do whatever logic that we want to do based on that. So the question, so we deal with the resources in multiple data centers as one pool? Yes, yes, yes. NFVO sees the resources in one pool, but also he can see the different data centers. So he can do this kind of projection. Practically, you cannot scale a VNF in another data center. That is not happening. But at least in the instantiation use cases, if there are no available resources in data center X, NFVO can say, you can do it, you know what, you can do it in data center Y. The last question, what is the fact on ground for the compatibility and interoperability regarding the promise of this standard flows Karim for each element? Frankly, the VNFM NFVO, that's the most mature reference point or a set of interfaces in the HCNFV. So there are a lot of good progress happening on the market for the VNFM and NFVO. I personally saw many vendors integrating with no issues. And even different vendors. So the VNFM NFVO, the MANO APIs are very mature, especially the VNFM NFVO. And that's where most of the logic are happening. Okay. So this is the last slide. And then I have some backup slides. I will show it to you. But I need like this round for the next session on Saturday. I need just to prepare for this activity because now we are in the middle of the program. So that's session number 7. And I'm planning for another like 7 sessions or 8 sessions till end of May. So we need, and even for me, I need to understand also your feedback and your impressions, and I get your feedback to make sure that it is reflected in the next half. So please, I need you to within your groups to nominate 1 or more. So you can have a video you can have video by 1 or maybe 2 or 3. It's up to you. I just need a 2 or 3 minute video as a reflection for the program's first half. What went well? What didn't go well? What most the valuable thing learned from your perspective? Was there anything new? What would you like to see in the second half? Any other thoughts? So please try to maybe offline work on this thing and nominate 1, or you can do a group video. It's up to you, and have this kind of reflection if possible. Okay, and please have it ready before next week session. Okay. Now I'm going just in few minutes going to give you a quick introduction about the coming slide, because you will find it in the shared folder. So this is the video. This is the video information element, the one that you see in the VNF descriptor. So you will see here the boot order, the software image description. You'll see the virtual compute description, what is CPU and memory for that specific virtual machine. You see the connection point descriptor, which is, as we said, maps to the VNF, to the VNIC of the VMs. This is deployment flavor. For example, when you start to say what are like the number of the VMs that you want to instantiate, and that what you see it in something called instantiation level. So do you need like 2 VMs, 4 VMs, 6 VMs? Scaling aspects, how you do scaling for that VMs. If you go a little bit deeper, you go now, I'm showing now you the video profile in the deployment flavor. You see the minimum number of instances, like what is the minimum number of the VMs and the maximum number of VMs that you cannot scale beyond. Okay, so these are like the information elements or the constructs that you see inside the VNF descriptor. I just brought it to you to be familiar with that. And if you need more details, you can go to the HC NFV standards. And for example, here, that's the instantiation level. And the instantiation level, you see something called VDU level. This is the exact number of the VMs or number of the VDU. So that's how the VNFD are structured and are constructed. So this was the last slide. Let me see if there are any questions. So for the video, guys, I put the videos on the shared folder. So shared folder will always have the videos. This is for the mentorship program, okay? And I put the slides in the shared folder. But for the wider audience, I also upload it in the YouTube to have more like for knowledge transfer and more benefits for the community. Okay. Thanks a lot. That was the 7th session. I hope it was useful and informative. If you have any questions, please feel free to contact me by email, and please just be ready for the next session activity. Thanks a lot, and see you next week.
Thanks. Bye.
Thank you, Karim. Thank you.
Thank you, Karim.
Thank you.
Thank you, Karim.
Thanks a lot, Karim.